do the experiment E1, Joule's law, okay, to verify Joule's law. So what we have is, what we need to do here in this experiment is we need to get a certain current flowing for a certain time, let's say 5 minutes, and we want to find the temperature rise in the water in that 5 minutes, and then we're going to change for different currents as we go along. Okay, so the apparatus, first of all, we use a circuit diagram very similar to the IV graph circuit diagrams. Okay, so let's put up. Right, so we have the same starting point. Okay, we have a potentiometer set up. Okay, so it gives a varying voltage. Remember, a varying voltage will give us a varying current. And then down here, in the actual main circuit itself, we have an ammeter to measure the current. We have a coil in water, which is going to be where we're looking at the current in that coil and the energy per second that's being changed into heat energy. Okay, and then we're back to here. Okay, we don't need a voltmeter in this case, so we don't need to bother putting it in. And we have a coil in water, and we have an insulated cup. Okay, there you go. Coil in water and insulated cup. That's it. Okay, sorry, we need to have a thermometer as well. So we have a thermometer inside the water. Okay, so basically that'll be the cup. This will be the coil. Okay, so inside the ceramic there is a coil. Okay, so if we broke that, okay, and I had a broken one in school, but I don't have it at home. Okay, it's actually a coil. There's a metal coil inside and that, so don't worry about the fact that it doesn't look like a coil. There is a metal coil in it. Okay, right, so let's look at what's happening. Okay, effectively it's going to be energy lost. We go the other way around. Energy gained is equal to energy lost. Okay, principal conservation of energy again. Okay, so what's happening is that the water is going to gain energy. Okay, if the water gains energy, it's going to rise in temperature. Okay, and we know that that formula is mc delta theta from earlier on. Okay, so m is the mass of the water, c is the specific heat capacity of the water or whatever liquid it is, and delta theta, remember, change in temperature. So it's a change in temperature from the beginning to the end, right? The energy lost. Okay, the energy lost is lost by the electricity, and we've just looked at Joule's law. Okay, and we said that the version that we are interested in for energy loss is the form of Joule's law equation is the I is P is equal to I squared R, or for the case of energy, I squared RT. Okay, so we have I squared RT. Now we have a very interesting formula here now, because we have 6 variables. Okay, now for drawing a graph to verify Joule's law, we can only have 2 variables. In other words, 4 of these variables have to be kept constant. So that's quite easy to do. Okay, so let's have a look. Okay, first of all, specific heat capacity. When I start the experiment, I'll be using water. Okay, when I finish the experiment, I'll still be using water. I won't halfway through decide we'll use vodka, okay, or we've used olive oil. Okay, we're going to stick with water. So long as we have the same material inside in the cup, it'll have the same specific capacity, so that's constant. So that one is sorted. M, the mass, I missed the mass of the water. Okay, we're going to have the same mass of the water each time. Okay, that should be fine. Okay, makes sense. Okay, T, same time each time. So in other words, if I'm for 1 amp, I'm going to do it for 3 minutes. For 4 amps, I'll do it for 3 minutes. That's pretty obvious, but we have to keep that constant. The trickiest one is R. The problem with R is that as the temperature goes up, the resistance will change slightly. So the way we can keep that is we can minimize that as much as possible is we always start at the same temperature. So in other words, I'm not going to do the first one and get a final temperature 23 and then start at 23 for the second one and get a final temperature 32 and start at 32. I want to go back and restart every time at 18 or at room temperature, whatever that will be. Okay, so we always do the same starting temperature. That ensures that R remains constant. We haven't done the experiment regarding the relationship between R and T. That's the next experiment, or the final experiment. We'll go back on that at that stage, but that's fine. Okay, so our 2 variables are delta theta and I squared. Let's remember all the time, x-axis, y-axis. Okay, it's going to be a straight line through the origin. We want one of our variables in the y position, which is clear in this case going to be delta theta. One in the x position, it's going to be I squared. Remember the formula that's going through the origin is just y is equal to mx. Okay, and we're going to leave RT here. We bring the MC around, and we end up with this form. It's in that form. Now there's a bit of work on that. Okay, make sure you can handle it. Okay, and then we have y equals mx. Okay, so the slope of this is equal to RT or MC. It's a bit confusing here now because m for slope and m for mass. So I just put in mw there, the mass of the water. Okay, so this is what you're going to do. Let's have a look at it. Okay, To verify the law, you're going to draw a graph of delta theta on the y-axis against I squared on the x-axis. When we do that, we expect to get a straight line graph through the origin. And to verify the law, listen carefully because some of you have been missing this. If you're verifying the law, you're saying straight line graph through the origin, therefore delta theta is proportional to I squared. Therefore, whatever's on the y-axis is proportional to whatever's on the x-axis. In this case, delta theta is proportional to I squared, and it'll say Joule's laws of 8. Okay, so that's verifying the law. Beyond that, then you could be asked to use the slope. If you're asked to use the slope, you get the slope in the usual way. Okay, and then we use this formula. So M is RT over MC. And for example, they could give you the mass of the water and the time, and they could give you the speed capacity of water, and they could ask you for the resistance. In other words, they could give you 3 of these 4 variables and ask you for the 4th one. That's it. You'll be doing one of those in the assignment. You'll see it's nothing different to what you've been doing all along. So that's the Joule's law experiment. That's how it's set up. We'll do it now, okay, and we'll get you to actually run through it. Okay, thanks a minute.